Hello everyone, I'm audible.
Yes, please continue.
Yes, sir. Good evening, everyone. So, welcome to the day 3. So, to continue, I would like to call Mr. Dhaval Mehta and start the session.
Is screen visible? Can I start? Only 14 participants are only there.
Yes, sir. Screen is visible.
Where are remaining? They have not joined.
So let us start in our time, sir.
Right, sure. So we have seen something that is that if there are more than two series and there are chances that co-integration, we have to check that the presence of co-integration is there or not. It may be that your original series is not stationary. Both, say for example, y, x1 and x2, they are not stationary. So, but when you run a regression, the residuals are stationary. So this is a first indication that possibly there are chances of co-integration. See, can you see this? If error is stationary, then there are very high chances that co-integration may be there. The other hint which can come is from that if your R-square is very much greater than Durbin-Watson, then that also is an indication that there are chances that there can be a co-integration. So there can be three possibilities which can happen in any regression, and from here we will have to take the call that what we have to do. So the first thing is all original time series are stationary. So I want quickly that you write down in the chat box that if all original time series are stationary, what you will do, what you will run. Please write down what you will do. Regression. Very nice, all of you. It's very clear that you will run normal OLS. Now my again next question is, suppose they are not stationary, what you will do? What you will do? Make it stationary, right? So there are two methods of making stationary. One is a medicine and another is a surgery. Medicine is log and surgery is first difference. Why I am saying that the log is a medicine? Because if you change the series by log, the ARIMA model, in ARIMA, I will always remain 0 only for log series. But when you make it first differentiation, I will be 1, second differentiation, I will be 2, and therefore it will change the original series. And that's the reason we say that one is medicine and another is a surgery. Fine. So you have understood that after taking the first differentiation, if it becomes stationary, fine, we are happy. Again, we will run OLS. But if it does not become stationary, or we have seen the case, then there is a possibility that we will have to go for checking of error for presence of co-integration. So let us see all the three scenarios. One of the scenarios we have already discussed. The first one, this one, regression analysis, right? So here, normal regression, we assume that all of them are stationary, and therefore what we will do, we will run simple y, we will make it log, right? LX1, LX2, LX3, this we have done it. This we have already completed it, right? And then we will go in quick estimate equation and we will write down Ly is equal to C constant, LX1, LX2, LX3. This is a simple regression which I am running, which I'll try to find out that is the p-value significant or not, probabilities are significant or not, and what is the Durbin-Watson and R square. That's fine, finish. Now here R square is less than Durbin-Watson. It is a very clear-cut indicator that there is no problem of co-integration, right? And all other statistics are also confirming, and that's a really good sign. So today we are going to start with the series. Series are integrated of order 1, that is stationary at first difference. The original raw series is non-stationary, but when I run them, the residuals are stationary. So the time has come to check that is there any presence of co-integration between them or not. And Arunima ma'am, I will request that please switch off your video. Thank you, ma'am. So hypothesis is there is no co-integrating equation. It means that we say that no model can be made, or there is no relationship between X and Y. Same is applicable here also. We say that there is no co-integrating equation, and here there is a co-integrating equation, right? So all of you get ready. There is one file which has been already sent to you, long run error correction model. Just check, are you having that file, long run error correction model? Please check it. Don't get disturbed. Even if you are not having it, don't worry, I will be able to send it immediately. Check it. Are you having that file, long run error correction, long run co-integration model? The answer is yes. Long run error correction model. Sorry, co-integration. Check it, all of you. Is it there? Please say yes or no. Right. Open it. Open the file. Done? Done? Are you with me, all of you? Open the file. Now select consumption, exports, and GDP by using the control button. Open as group, and you will get this. Got it? Check. You got it? Now go in quick. Estimate VAR. Now it's very surprising that why we have to go in VAR. It is a vector autoregressive model. Please listen carefully to me. See, still we have not run the co-integration equation, and we are running VAR directly. Now the menu, or rather which lag coefficients, how many lags will be affecting my dependent variable, I cannot get that environment until and unless I run VAR. At present, I'm not going to interpret anything from VAR, but my basic requirement which I have to fulfill is how many lags are going to affect me, that I want to estimate. And that is only possible after running VAR, right? But we will not interpret any equation of VAR. We will just skip it. We will run VAR, and we will take another menu so that a lag coefficients are generated. So quick, estimate VAR, right? And write down cons, exports, and GDP. Cons, export, and GDP. Standard VAR should be on. 2 lag intervals are to be considered. Click OK, and you will get the answer. You don't have to see anything. You don't have to interpret anything from here. We will skip it, and we will directly go from here in view. I'll click on view, and the lag structure, lag length criteria will appear. Done? Is it done? Say yes or no. Fine. Lag length criteria. Yes. When you click on it, a window will appear. It will ask how many lags you want. So specify that I want 3 lags and click OK. 3 lags. Yeah, by default it is 3. Let it be. No problem. Done. Okay. Now, wherever you get a maximum asterisk, that then you will consider that this is the lag which is going to affect. See the asterisks. Now there are different criteria for selection of the lag, like Akaike information criterion, Squads information criterion, Han and Quinen information criterion. But most of the time we rely on AIC and Squads criterion at the most of the times. If they both tally, then it's clear that we will be running on 3 lags, right? We're running on 3 lags. Right, we will do nothing, but what we'll do now, again we will go in quick group statistics. You can go from quick group statistics and click on Johansson integration test. Quick group statistics, make sure that you have selected all of them. Repeat. Yeah, the repeat is most of the time we rely on Akaike information criterion or a Squads information criterion. They two are best, right? And if they both of them tally at the particular lag, that lag is considered for our analysis. In case of dispute, wherever maximum asterisks are there, you will have to do that. But don't go for taking 4, 5, 6 lags, because by taking more and more lags, the model will become over parameterized model. We don't want over parameterized model. We want parsimonious model. This I will explain. Over parameterized in the sense, when n is greater than 50, when n is greater than 50, use SIC. Ansul ma'am, is there any source for this information? Ansul ma'am, is there any information? Yeah. So what is the source? When n is greater than LR. Okay. So Ansul ma'am wants to say that when n is greater than 50, use Squads information criterion. Okay, fine. If possible, Ansul ma'am, try to drop the literature today. Fine. Let's proceed further. Now go in, select all the 3 quick group statistics, Johansson co-integration test. Done. Are you here? It will not appear until and unless you select all 3 of them. Then only the group statistics will appear. Done. What tab? Tab is not appearing. Done. Are you here? What value is checked to get 3 to lag 3? We are checking Squads information criterion or Akaike information criterion. So it will ask for some specifications, right? Now see, you can either specify cons, example, GDP, or if your window is showing this thing, make sure that your third model is selected and you keep lag 1 only. Only 1 lag is considered as per VAR approach. Only consider 1 lag. AIC criterion, Ruchi ma'am, AIC criterion. Okay, AIC criterion. We don't have any standard value of AIC. We say the smaller is the better. If we are comparing two model, the model whose AIC value is lower is a better model. That is a Kaike information criterion. Basically, it's a penalty parameter. And if we are having any AIC on which the asterisk is there, then we consider that lag. Okay, all of you have specified this thing. Please write down quickly. This is 1-1. The tick should be on 3. Done. Please write down in chat box yes or no. Quickly, all of you. Barkha, Rohit Lala, others, please write. It matters a lot. Please, others, write. I want yes from all of you. Otherwise, I will not move ahead. Right. Now click OK. Click OK. And immediately you will get this result. Now in this result, it's very interesting that we have to see that where the p-value is more than 0.05. Why? Because our null is no co-integration exists. And therefore we want to reject. We want to reject null. But it is very interesting thing that we have to proceed in a way, and the method is how to read this table. Let's understand. The first hypothesis is there is no co-integration equation, p-value less than 0.05, reject it. So first hypothesis is rejected, none rejected. Now comes the second. There is at least at the most one co-integrating equation is there. P-value more than 0.05, done. This equation, we are accepting this hypothesis. It means that there exists one co-integration equation. P-value should be the point at which the p-value becomes more than 0.05 is the number of co-integrating equations which we are having. Check it. Is it so? Is it so? Check it, please. Right. Same thing you can interpret from unrestricted co-integration rank test. From here also you will get the same thing. Both the tests will be working in the close proximity. Results we will be getting more or less similar. So this is based on test statistics and this is based on maximum eigen. See here also you get the number of co-integrating equations are 1. So it means that there are at least, see how many variables are there? 3. So how many minimum co-integration equations which can exist? 2. If you recall, we had talked about that game in which there are 3 boys which are running, right? So how many laces are there or how many ropes are there to tie? So we know that we require 2. So 3 variables are there. And therefore the test will also run in such a way. None, at the most 1, at the most 2. You cannot have 3, right? Fine. So this we have cleared, and it is very well, it's very well saying that now we will have to proceed a little bit ahead and just scroll it a little bit. You will get a Johansson integration test. It will be below this. Check it. Is it there? Co-integration equation will have been generated. Is it there? It will be below, exact below it. Now, consumption is a dependent variable, right? Minus 347 is the coefficient of export. Minus 637 is the coefficient of GDP. 2.775 is a standard error. When I divide this with this, I get the T value, which if it is more than 1.96, it means that your P value is very significant, right? So here signs of export and GDP is negative. The signs of export and GDP is negative, which means that as GDP and consumption have negative association in long run. Similarly, consumption and export also have negative association in long run. Is it clear? Sign is negative. Signs are negative, right? So with every increase in 1 unit of export, the consumption decreases by 3.47. If every increase in 1 GDP, consumption decreases by minus 6.37. Now, whatever relation which I have got it here, remember it is a long run relationship, not a short run causality. It is a long run association which is there. And you will have to confirm that these theories are in the confirmation, these signs are in the confirmation with the model or not. See, basically War, Wacom or Arima, they are a theoretical model. We don't have any theory behind this thing, right? And therefore, but we are running all of them. I may be wrong, but in normalized equations should be reverse. I agree completely, Anshul Agrawal. That thing is coming later on. That thing is coming later on. See, Anshul, listen carefully. Anshul, listen carefully. If this is plus, this is minus. If this is minus, this is plus. And therefore, anyway, it is going to affect in the same way. What you are saying is correct, right? But this is plus, this is minus, this is minus, this is plus. It's going to affect in that way only. Now, if series are co-integrated, then they exhibit a long-term relationship. We will stop here in the sense that this is the end point. That if the co-integration exists, it's a very clear-cut indication that the co-integration exists. If it is existing, then we will be using VACM, vector error correction model. And if it is not existing, then we'll be using VAR. Write it down. Please write down on one page. If co-integration has been established, then we use VCM, vector error correction model. And if the co-integration does not exist, we are using VAR, vector autoregressive models. Got it? Shall I proceed further? Shall I proceed? Okay. Now comes the third scenario. PC is running slow. Now comes the third scenario, right? Now here, series are integrated of different orders. Their combination is of I0 and I1, right? Is it clear? So we cannot run the co-integration test, and it's no longer valid to run this. But there is something which is the bounce test has been proposed by Paschran, Seen, and Smith in 2001. They have proposed this test. Now, all those who want to go on the next level of econometrics, has anybody heard about the name Paschran? Please be frank enough. Have you heard about the name Paschran? Paschran and Paschran? Anybody? No. So it's an entire new level of econometrics which they have talked about. They both are brothers and they are professors in London University. Now, why I want to say about them is that they have written a book of econometrics which is costing 28,000 rupees. One. Second thing is they have developed one software and they have kept it in open source. And the name of the software is Microfit. Microfit. And it is having much more powerful applications in respect to EViews, right? So possibly within next or the next 2-3 months, we are going to launch a program on econometrics using microfit, right? Now, what is the advantage of this? All limitations of EViews and Gretels have been removed in this. For example, you cannot run multivariate GARCH in EViews, but here in this Pesheron and Pesheron microfit, you can run multivariate GARCH, DCC GARCH, back GARCH, BEKK GARCH. All these things are possible in that, and it's completely free. Now, what they have said about this particular thing, they said that if the series are of different thing, I0 and I1, before running ARDL model, you run the bounce test and then you take any decision. So how we are running the bound test? Let us understand. And what this model is. Here, the model is C, very clear. We will not have a different, here a different lag will be used for Y, different lags will be used for X, and therefore red ones are the auto-regressive terms, the blue ones are the distributed lags, C. These are AR terms, very clear. And these are distributed lags of some another variable. And that's the reason we say it is an auto-regressive distributed lag models. Clear? And ET is a random disturbance term, right? Or we say that we want white noise in it, or rather it should be stationary, right? Lags P and Q can be different and they should be different. Any questions are there? Please ask. No? So we want to run, before running ARDL model, let us run bounce test. And what is a null hypothesis? There is no co-integration equation, right? All these things you will not be able to understand anything. But when I run the test, no, I have made the pictorial representation so nicely that you will be able to remember. And I always give a key so that how to remember this software. That key I will give it to you. Okay, all of you go there in long run co-integration model. You already are there in the model, and make sure that now you open as group. Done? Done? Right. Now go in quick estimate equation, and there is a ARDL model here. Open that model. Those who are using lower versions than 10, they will not get this option. So don't try to figure it out. You will not get it. Done? Right. So cons X GDP, maximum lag is 1 of dependent variable. So if cons is there, I will take consumption -1. And for regressors, X and GDP, maximum lag is 1. So X -1, GDP -1. The restricted constant is there, right? This is there. Click OK, and you will get the answer. Done? Got the result? Did you got the result? Okay. Now, how to evaluate this? Please repeat from lakhs. How much I will have to go back? Yeah, here. Maximum lag 1, regressor, maximum lag 1. So when I specify that dependent variable, only one lag is to be done. Consumption 1. So consumption and consumption -1, and on regressors, export -1, GDP -1 will be considered. Click OK. Done. Got it? Fine. Now we want to evaluate this. So we will not do any analysis here, and we will bypass this. And now we will run view coefficient test, long run and bounce test, long run form and bounce test. Done. Is it done? All of you, please write down. Done. Now you will get these values when you will click OK. Right? You will get these values. Now, what you have to observe is that if the F value, this value, right, is less than I0, this one, we cannot reject null hypothesis that there is no long run relationship and co-integration does not exist. Okay, and therefore we will be using ARDL model. But if F value, this value, is higher than I1, right? If is higher than I1, either it can be less than I0 or higher than I1, then we are going to use VACM model. Wait, I know you are getting disturbed. Remember this graph. Remember this. If I0, if the value of F is less than I0, ARDL, if it is more than I1, value of F, ECM. Now see carefully and read. Whatever you want to do, write it down. Is it clear? Now, what is your take here? See, the F statistics is greater than I1. And which model you will be using? Please write in the chat box. Right, ECM model. So we have resolved this also. Now, let's start running the model war. Clear? So these three scenarios we have bypassed, or rather we are clear in the decision-making approach that what to do in which scenario, right? Any questions are there, please ask. Any questions are there, please ask. Right? So the first method, I'll close this. And I'll start with war. Now in somewhere around 1980, I think so. It is 1980. Yeah, 1980. Sim, the academician wanted to say that why we are making a demarcation between the dependent variable and independent variable. There should not be any demarcation. It means that rather making anything dependent and independent variable, we are doing, we allow we allow a vector approach here. It means that at one moment of time, yt will be a dependent variable and all others will be regressed on it. Then xt will become dependent variable. Then zt will become dependent. So this is the concept of estimating VAR model. And here we don't have any such concept of which is dependent variable. Basically, this is a system which is running, right? And when we are using VAR model, when we are very clear cut on one matter, that the no co-integration exists. There is no co-integration between yt, xt, and zt. And then we take the decision that out of these three, which is the most influential, or rather, which model should be I consider on the basis of Ikaike information criterion, that this is my dependent variable and this is my independent variable. I am not taking any decision that I'll be running yt, xt, zt. I will allow the system to take the decision. Is it clear? But there are some concepts which we'll have to understand. Autoregressive. Presence of lag value of the dependent variable on right hand side is there. There is a vector which contains vector of two or more variable. VAR model is constructed only if the variables are integrated of order 1. It is necessary that your variables are integrated of order 1 or first difference, that is stationary at first difference. If the variables are co-integrated, construct both short VAR and long run VECM model. If the models are not co-integrated, construct only short run VAR models, right? All the variables in VAR system are endogenous. They all are dependent. There are no exogenous variables. Dependent one function is function of its own lagged values and lagged value of other variables. VAR must be specified in levels, and VAR in difference would be a misspecification, right? This we will see when we are doing it practically. The prawns is the econometrician does not have to worry about which variables are dependent or independent. Second, estimation is very simple. Third, forecast of the VAR can be obtained very easily. The cons is it is a theoretical model. A theoretical model means it is not supported by any other model. The another problem is that if I say 2 legs are to be taken for each and everything, see how much the model will expand. If I say 3 legs are to be taken, the model goes on expanding like anything. More the model, the more it will become over parameterized model, and it will not give me a good result, right? This we have already seen. We will carry out the unit root testing if they are integrated at the same order. If yes, we will say Johansson co-integration. If co-integration exists, then co-integration does exist, we will be running VECM. If it does not exist, bounds test is used or Granger causality is used for further process. This we will see. Now, this is a thing which I have understood, that how it is working. Is the PPT visible? Say yes or no to all of, say all yes or no. Is PPT visible? Please pay attention to your highest level, right? Please pay attention here. Now see, yt is dependent, xt is dependent, xt minus 1 is a lag of xt, yt minus 1 is a lag of yt. Now how VAR is working? I will say yt is dependent on xt, xt is dependent on yt, yt minus 1 is influencing yt, xt minus 1 is influencing xt, xt minus 1 is influencing yt, and yt minus 1 is influencing xt. This is VAR. Clear? Is it clear, Surjit Kumar? Is it clear? This is how VAR is working, right? Let's proceed further. Now, those who are not coming from the mathematics background, no need to worry, right? Basically, this is a matrix system which they have developed, in which there is a matrix which is running. So suppose there are three variables. So we will list down like yt minus 1, xt minus 1, and the coefficients are taken, and this is an error term. State your research objective very clearly, perform unit root test, obtain optimal lags, run unrestricted VAR model, perform some causality test, perform some diagnostics, variance decomposition, and impulse response function. So from here, we start how to write the research objective. So I'll write using a VAR model to investigate the relationship between GDAB and export if there is any significant impact from shocks. Then we will do unit root testing. It is necessary that they should be integrated of the same order. Step 2, all of you get ready. Long run co-integration model, open GDP, right? Come till here. Come up till here. If you are done with this, write down in the chat box, done. Okay. Open as war. Now my question is, I have written consumption here, export here, and GDP here. Which variable is a dependent variable? Please write down in the chat box. Which is a dependent? My question remains as it is. Which is a dependent variable? All of you write your answer. Yes. So some people have still made the mistake. Understand one thing. You are in the environment of war. And here there is no concept of dependent variable. All the terms are endogenous. I am repeating again and again. It means that system will run the equation, three equations it will run. First time consumption will be made dependent variable, then export will be made dependent variable, and then GDP will be made dependent variable. Is it clear? Write down in the chat box, yes. Okay, click OK, and you will get the answer. Are you getting this answer? Say yes or no. Are you getting this answer? Right. But still, we will not interpret anything from here. Still, the lag length criteria is left out. Again, we will go in view, lag structure, lag length criteria, specify 5, click OK, and tell me how many legs are to be included. If I will take 5 legs, the system will blast, right? What will happen is, just imagine that there are three variables: consumption, export, and GDP. And I am running 5 lakhs. So in total, there will be 15 lakhs, right? For one equation, there are three equations, and therefore 45 parameters has to be estimated. And therefore, it will be a totally over parameterized model, and therefore it will create a problem. In war, never ever increase beyond 2 lakhs. Is it clear? Never ever increase beyond 2 lakhs. Otherwise, your R square will become deflate. R square, you will get R square. Most of the time you get R square 0.99, something like that you will get it. So never ever in war go beyond more than 2 lakhs. Is it clear? Please write it down somewhere. Now, after estimating the lag, again I go back, and this time I specify 2 lags. You use appropriate lag length criteria here. And now again I will run it and click OK. Got it? Are you here, all of you? Say yes or no. Now let's start interpreting, right? Let's start interpreting. This value, which is in the bracket, it is a standard error. The difference between actual and predicted. So when I take the division of the standard error and the difference between actual and predicted, it gives me the T statistics. See, 12.377 divided by this will give me the T statistics. And we very well know that if the T value is more than 1.96 plus or minus 1.96, we will reject. We will reject the null and we will say that it is a most influential parameter, right? Just try to figure out in this 21 parameters which are there, that which value, see, in square bracket, it is a T statistics, where 1.96, it has crossed 1.96. Tell me that thing. In square bracket. So you will find that this method is not appropriate and it takes a lot of time. Okay, I deliberately wanted to make you understand that what it is doing. We found that there is no single value of T statistics which is more than plus or minus 1.96. Do you all agree? Write down in the chat box. it means that neither of the coefficient is significant, right? Neither of the coefficient is significant. It means that when I will calculate the p-value of all of them, it will be greater than 0.05, right? Now, how will I do that? So for that, there is a procedure. There is a procedure, right? The procedure is let me directly go there. Okay, let me directly go there. Wait a minute. Let me run the equation because here it will take a different path. Theta is long run here, and here I'll say quick estimate var done, cons x GDP done. This is also done. So you all are here right now. Now do one thing. Go in proc, make system, and order by variable. That make system order by variable. Got it? Got it? Now just select all of them. Estimate. Click OK. And you will get the p-value. Now see the p-value of all of them. Neither of them are having more than 0.05. Is it there? Is it there? Check. All values are above 0.05. Say yes or no. Fine. And therefore, we don't find any relevance here. Now, this will come later on. But again, we will have to move further to establish the causality between them. Right? We will have to establish the causality between all of them. And what causality means? X causes Y, X leads to Y, X is only one of the possible cause to Y. And therefore, we want to run some causality in between. Now, just imagine how many types of causality can be running. If I am having that graph, just a minute. Wait a minute. If I am having it or not, just a minute. Huh? Okay. See, pay attention here. This is not downloaded from anywhere. I have just tried to visualize the matter. Is the screen visible to all of you? Say yes or no. Please pay your attention. See what is the thing which is happening. Export is there. GDP is there. Consumption is there. Now this is a system which has been made, right? So first thing is there are lags of GDP, GDP minus 1, GDP 2. Consumption, consumption minus 1, export, export minus 1, export minus 2. Clear? Now there can be that this GDP lags are affecting, and for this we will be running individual t-test. Clear? Is it clear? Right. Consumption affecting GDP, export affecting GDP. For there we will be using Granger causality or block exogeneity test. Clear? Okay. Now, all together affecting each other, all together means not individually minus 1, but the entire group of lags affecting the dependent variable, that will be tested by Wald coefficient test. And export, is it two-way relationship or not? will be tested with pairwise Granger causality test. So many causalities we will have to test. Is it clear? Because we are in the war model. I hope things are clear. You can take the screenshot of it. This is not downloaded from any book or not from any YouTube video. So shall we start with the test? Okay, let's go back. And we'll start with the first test where we want to see that is legs affecting or not. So for that purpose, we already have that this model is there. We have seen as neither of the t-tested statistics is greater than plus or minus 1.96. So these variables are not significantly contributing. So first way of causality is gone, right? No lags are affecting dependent variable. Clear? Please write down in the chat box. Done. Okay. Next comes second way of causality. Again, go in lag structure, view, lag structure, and run Granger causality block exogeneity test. No, Rohit Lala, this is Rohit sir. This is not the book. I am having this book, Hasim Peshran. This is not that book, sir. It is Peshran and Peshran. I am not getting its copy. This book I am having it. This book is there. Both the brothers have written together, Peshran and Peshran. This book I am having it. Okay, click OK. All the lag coefficients of GDP are not causing cons. See, consumption and export and GDP. See the p value. So consumption is getting affected by GDP. 1. Export is getting affected by consumption and GDP. And GDP is getting affected by consumption and export. Export will not come because it is more than 0.05. So we can say that there is a significant effect of all lags of GDP on consumption. Clear? Second causality established. Shall I proceed further? Please write down in the chat box. Hello. Shall I proceed further? Is it clear? Fine. Now, how we report it? We say consumption, X and GDP both significant at first leg and second leg. In Granger-Wald test, we say GDP is significant. For exports, we say that in T statistics, first and second leg was insignificant, but consumption and GDP was significant. GDP, this was insignificant. Here, export and consumption was significant. Most of the time, both the tests tally with each other, but if there is a dispute, we cannot avoid it. Now we want to run third type of test in which we say that all lags collectively are influencing any variable or not. So we go in view coefficient diagnostics Wald coefficient test. And here we will write the collective null hypothesis, the joint hypothesis that C1 is equal to C2 is equal to 0. Why we are writing joint? Just a quick recap so that you don't get lost. Quick recap. See, why I'm writing C1 is equal to C2 is equal to 0? Because I'm carrying out the Wald's test. This is C1, this is C2. I'm saying jointly, they are not affecting consumption or not. So that's the reason I'm making a joint hypothesis. So C1 is equal to C2 is equal to 0. Click OK, and you will get the result. Here p-value is more than 0.05, and we say that jointly lags are not affecting consumption. Done? Is it done? Shall I proceed further? Shall I proceed? Write in chat box. You will have to run the Wald coefficient test for all of them one by one. Now C3 by C4 equal to 0, right? Then we will say C5 by C6. Now comes the pairwise Granger causality test. Why is Granger causing X, right? Y is Granger causing X and X is Granger causing Y. The basic condition in both of them is they should be stationary. If not, then make it stationary and then apply Granger causality test. This is a basic condition which we should remember. Okay, all of you go in quick group statistics, Granger causality, fourth way of testing the causality. Write down cons, export, GDP. Your last lags. Click, make it 2, click OK. right? Here, the p-value is more than 0.05 in first case. Now understand one thing. It's very tricky to interpret. Export does not Granger cost consumption, right? And if we reject points, if it is less than 0.05, we don't say that the consumption, if this direction is not correct, this direction is true. No, not at all. Both the directions are independent. Export to cons is independent of cons to export, and therefore individually they are tested. And therefore, if it is getting rejected, see the second part, if it is getting rejected, it means that GDP does not Granger cost consumption. It means that if it is getting rejected, GDP Granger cost consumption. Got it? So here it is a bi-directional relationship which is there. Clear? Is it clear? Okay, let's proceed further. Now from general to specific model, we have understood that those variables which are not affecting have to be removed, and we have to come with a very specific models, a model which is having less number of parameters. So for that purpose, we go in coefficient and diagnostics, Wald coefficient test. And we go from this, remember this setting, not this setting, this setting, because the menu will be different, view menu will be different here, here, here. Don't think that all the view menu will be same. Okay, run. Now I will write down entire equation from C1. Is any of the parameters significantly or jointly we are able to make the model or not? Can I make the model or not? So here I write down C1 is equal to C2 is equal to C3 is equal to C4 is equal to C5. I enter everything that can the model be made or not, right? This you do it later on. It is there on your screen only. You do it later on. So what I get is I get p-value less than 0.05. Now this is an indication that fine, if individual p-values are not significant, but there is a hope, as we are rejecting the p-value here 0.05 is its value is less than 0.05, so there is a hope that the model can be created. But now we will have to handpick the coefficients, handpick the variables. The coefficients have to be handpicked. How we will do that? Let's see. Make system order by variable, and you will get this. Now, one by one, we will start. How we will use this? Those coefficients which are very near to 0.05 will be picked up. See, very near to. So I will say that I am picking up C6 in the model, C2 in the model. Let's see. And then I will run this much only. So get ready. And instead of the entire thing, write down consumption is equal to C2 asterisk consumption minus 2 plus C5 GDP minus 1 plus C7. You can delete the equation in that window. You can delete it. Done? Is it done? Fine. Click OK. Estimate. System equations. Okay. And you get something which is very meaningful. C5 and C7 are the significant parameters. So initially what we found that there were a whole range of parameters which were significant, which were not significant, and we were not able to get the result. So we went for Wald coefficient test. Suppose if the p-value of the Wald coefficient test was more than 0.05, then the last hope was also not there. That there is not a single variable on which the model can be created. But as the Wald coefficient indicated that there are some parameters in which you can make a model, we came here. Clear? Write down in the chat box, done. Please write it down. Right. Let's proceed from here. Now, there are some diagnostics which we will have to perform. That we have made this. Please show the last equation. Yeah, the last equation is here. Okay. Now, there are some diagnostics which we will have to perform. That just imagine that we are trying to fit the model to the data, and whatever is the left out is a residual, right? I will explain this thing in a very simple way. Okay. The simple way is that there are tailor-made certs and there are something as standardized certs which are available in the stores. Is it clear? Are you with me, all of you? Can you listen what I'm trying to say? See, there are tailor-made cert, right? And there are ready-made cert which are available in the stores. Now, just imagine that your body is data. So if it is a tailor-made cert, definitely what will happen? It will be a very close fitting and it will be very well fitted, and the chances of the error are less. But if I'm purchasing the ready-made one, what will happen? There will be a problem of fittings and there will be an error in the sense loose fittings will be there. So here, what we are trying to do, after fitting our model to the data, we are trying to find out that is there something residual value which is left out? Is there some problem in the model in prediction? That we are trying to do it. Clear? Fine. So we are going to perform the serial correlation test, and then we will then that is view residual test, autocorrelation, LM test. Remember one thing, on that day also I told you the same thing is that for residuals, the p-value should be more than 0.05, and for the model or everything, causality, the p-value should be less than 0.05. So here we are in residuals, we are looking for p-value more than 0.05 because our null is there is no autocorrelation. Done? Okay. Next to include 3, click OK. So we can see that at lag 1, the p-value is less than 0.05, and it is an indication that there is a presence of serial correlation here. Right? There are chances 1 and 2. In fact, both 1 and 2 are affecting the right. So serial correlation present. Done. Let's proceed further. So we have tested the first type of correlation, that is a serial correlation. Do you remember my concept that one devil should not be associated with another devil? Did I give you that example? Hello? Did I give you that example? Say yes or no. So it's the same thing. One devil getting correlated with the another devil, and that is the legs are getting correlated. That is serial correlation. That can create problem. Fine. Now comes normality. So here normality test is being conducted. Done. Right. Click OK. Cholesky of covariance, Lutikopol is to be considered. Click OK. And what we find that the p-value is more than 0.05, and therefore it's a very good news that the component for 1 for consumption, component 2 is for export, component 3 is for GDP, and they all are normally distributed, which is very nice. Just scroll it a little bit. As the p-value of the JARC-PARA test, which is generated at the last JARC-PARA, is more than 0.05. So here we are talking about the joint residuals in VAR system, jointly, not of consumption, not of export, not of GDP. Overall residuals, is it normally distributed? And we can see that this value, this one, is more than 0.05, and therefore we can say that the overall error is also normally distributed, which is also a good news for us. Right. Third category, the error should not increase. The devil should not increase its power. So for that purpose, we are using residual test, and it's a white heterogeneity test. Right. Click OK. And what you get here is again the p-value is more than 0.05, and therefore what we get is that the residuals are homoscedastic. So this is also a good news for us. Done. Next. Now we carry out the variance decomposition. Perform the variance decomposition, basically known as a spillover effect, or how much is the effect which is carried out, or it is also known as how much shock the system is having, right? And it is we carry out in a VAR model. How it is done, let us see. Go in variance decomposition, view variance decomposition directly. It will ask you, please, do you want the table? None. Consumption X GDP periods 5. That the effect, the shock given in the consumption. Say for example, if I am giving one shock, see, in the layman terms, if I will explain this thing, what it is, then try to observe statistics in your real life. And to give this example, the real life example is, that a person is holding a string, right, which is attached to the hook here. There is a hook. Now he gives one shock. So what will happen? The maximum shocks will be here, then it will be here, then it will be here, here, and it will phase out. So any shock given on a particular variable, what will be its effect at 1 lakh, 2 lakh, 3 lakh, 4 lakh? That way we are trying to estimate. Is it clear? Write down in chat box. Done. Right. Let's proceed. Go in variance decomposition, cons, exemption, then GDP. 5 periods. Cholesky decomposition, click OK, and you will get this type of answer. Right. But instead of going in table, see, table are less self-explanatory. So instead of going in table, again go in view, variance, decomposition calculus, and make multiple graphs. Multiple graphs. Click OK. Somebody had posted me regarding this thing that, sir, when this will come. See, this is the time period which has came. So what it is telling me, how to interpret this, we will understand. How to interpret this? Let us see. For consumption, these are the lags which have been carried forward in second, third, fourth, fifth lag, right? Just see how it's there. Consumption, then export and GDP. Similarly, consumption, variance decomposition of export, right? Then consumption, GDP. So this is the way in which the matrix has been constructed. Now, total, row-wise total will always be 100. See? Is it clear? Now, let's proceed further. Let's proceed further. Increase in export by 1 unit decreases consumption by 827 units. See here. 827. Interpretation is same as regression. Increase in export by 1 unit decreases consumption by 827 units. Interpretation is same as regression analysis, right? But what about the shocks? These shocks which are there, 1 and 2 is considered as a short run forecast, and 3, 4, 5 is considered as long run forecast. Now, how to understand this? Consumption. This is consumption. Effect of consumption of its own lags is very significant. See, is very significant in the subsequent lags. But effect of export on consumption, the lag of 1 lag of export, 2 lag of export, 3 lag of export, and its effect on consumption, effect is very, very less, 9%, 7%. But the most significant thing which was observed is this one. That in the case of GDP, there is a higher effect of export. It is prominent till 5th lag. It means that the export done before 5 years are also affecting GDP, and the explanatory power, the variance which is coming from that 5th year export is 14%. Right? Is it clear? The most glaring other thing which is there is, see, in case of export, The 5th year explanatory variance, 46%, is contributed to the present export. Clear? Write down in the chat box. Clear? Right. Let's proceed further. Now perform some impulse response function. Again, go in impulse response. View impulse response. Make consumption impulses. We want to see the shock, export and GDP in responses. Make it multiple graph, analytical, export GDP. Click OK. And you can see that this graph gives response export to 1 standard deviation shock of consumption. It means that if we are moving the string by 1 standard deviation, this on x-axis there are lags. The graph shows that a decrease of export is in 1 to 8 period, and the graph shows decreases of GDP in 1 to 8 period. The graph is decreasing, right? Even though the shock is given. Now, if the last test, which is there is view leg structure, AR roots graph. The last, I know you are tired now. AR roots graph. If all your dotted points, blue dotted points, are inside the circle, it clearly means that your model is a good model. Right? Clearly means that your model is good model. Are all your blue dotted lines inside? Done? Say yes or no. Hello, say yes or no. So it means that this model is stable model. The model is a stable model. Right? This is not required. This is required. View residual test and correlograms. Click OK. All the points should be in the dashed lines in the plus or minus 3 sigma. Right? The dotted points should not cross the dotted lines. If it is, then your model has been made a good model. Right? So we'll start with now VACM. I hope you are all not tired. It will not take more time because the steps are repeating in VACM. Shall I proceed further? Say yes or no. Shall I proceed further? Okay. We'll start with VACM model now. Now VECM is normally used. We have understood this thing that VECM is normally used when you are getting co-integration equation and when you have to specify that how many co-integration equations are there. In general, it is a linear combination of I1 series is also I1. However, in some cases, linear combination of I1 series is also I0. So something very special happened for a linear combination to become stationary. Why I1 cannot be used in VAR? If you run VAR in levels, that is I1, it is mostly likely that impulse response of this variable will not tend to decay because already you have different. See what this concept is. You can give shock to a system when these strings are the middle, the string in the middle is free. But when I already difference this series, right? If I'm breaking the series, just imagine that the series is broken, right? The entire thread is broken. It has been differentiated. Now, if I give one shock here, Will impulse response function? No, it will not function because the thread is broken, the data has been broken, and therefore there is no continuity in the data, and therefore impulse response function will not work. Clear? Right. Now I want to run VACM. So there are some basic steps. All the steps are going to be repeated. Just a minute. I'll directly start with the model. Yeah. State the research objective to apply a VACM model in investigation, the relationship between M2. Same. Perform unit root test, obtain optimal lags, perform co-integration test. If co-integration exists, then estimate VACM, check causality, check diagnostics. Everything remains same. The only thing which changes is how to activate the option of VACM, right? So let us see the step one by one. Perform unit root test, which we have done. You don't do anything. The file has already been given to you. This is a homework which you have to do. I will slowly roll the slide. You don't do anything. So I will say money ITA. Just please check, all of you. Money ITA file is there with you. Please check it. No, I'm doubtful about that matter. Is it there? No, it's not there. No, I was having a doubt. Right. I'm sending the money ITA file to you. Got the file? Please confirm. Please confirm you got the file. Say yes or no, file is running. I have sent this file in the chat box. Kritika ma'am, Zoom chat box, please check it. I am also sending in WhatsApp. I also sent it in WhatsApp. Okay, now please pay attention here. So from where I have to start? First, I have to perform the unit root test. It's an homework for you. You don't do anything right now. Just pay attention. Then you go and estimate VAR. We run VAR model. And after running the VAR model, my question is, why we are running VAR? Unit root has been done, stationarity has been checked. Why we are first running VAR directly? Please post your answer. Yeah, for getting the lag, and that is only possible in the environment of VAR. So view, obtain the optimal lags. We go here and lag line criteria, it has been specified, and then we take the lag. Done. Once the lag has been specified that this must be the lag which must be affecting. Now where we go? Can anybody tell me where should I go now? Lag has been specified. Now where should I go? We are clear with this much lags are being generated. Now what we should do? Any hint? Now we will run co-integration test and we will check that co-integration is present or not. So co-integration test, Johansson system co-integration test, view co-integration test, Johansson system co-integration test, and we will say 2 lags I'll be considering. Okay. Is there any presence of co-integration? Say yes or no. It's the same test which we have run. Same thing which we had run. Is the presence of co-integration there? Say yes or no. Yes, the co-integration is present. Yes, Ansul. Co-integration is there. See. Oh, sorry. No co-integration is there. Yes, Ansul ma'am, you are right. No co-integration is there. I thought that it is 0.015. So there is no co-integration present because the null hypothesis is that there is no presence of co-integration. P-value is more than 0.05 and therefore we accept null and there is no co-integration. Right. In case, suppose a co-integration was there, then what we would have done? I would have gone in open as var. Right. I would have specified this thing. But now instead of standard var, I will shift this button to VCM. I'll shift this button to VCM and I will click on co-integration and I'll specify that number of co-integrating equations are 1. Is it clear? Is it clear? Say yes or no. Done? Yes. Now click OK. So in case of normalized co-integrating coefficient, signs are to be reversed. We reverse these signs, right? And if you don't want to reverse, then also don't worry, right? I am having a technique. We all have that technique. What to do? I will go in proc. Okay, I will go in proc and I will make, normally this equation is written like this. But before writing this equation, let us directly go in proc. From where I'll go, just a minute. Yeah, make system order by variable from that window only. Make system order by variable and it will generate this thing. Now the thing which you should remember is that in VECM, that this D, it means that it will always generate the first difference of the series on its own, right? And we will get 2 equations. One, C1 is the error term or an error coefficient, and C2 are the normal terms. When I will select the upper row, just upper row, and when I will run it, I will get this type of equation. Now the most desirable condition here is that the C1 term should be negative and it should be less than 0.05. Is it clear? Why so? Because we are saying that it is co-integration equation, and therefore now let us come back here at what is the concept. C1 is negative. It means that it is correcting the speed of it. It means that suppose the series starts deviating, immediately a shock will be given. It starts moving this side. Now if it goes a little bit outside, again the shock will be given and it starts correcting. It is like that. I had given you the example that 2 boys are running together. So if this goes a little bit out, the pulling will be done. And therefore this pulling can only be done when the error coefficient is negative of the system. That if it starts increasing, this starts decreasing, then only the correction will be done. If both are positive, what will happen? That this boy is running and this boy will also start running in this direction. So to correct this, we are in the requirement that this should be negative and significant. Is it clear? Write down in the chat box, yes. Write down in the chat box, yes. Is it clear? Others, please write down. The basic requirement in VSCM is, it is a correction term. First term should be negative and significant, right? Now, this is the rate at which the correction is being done. If I convert this into the percentage, the speed of adjustment is 1.6%, and therefore the speed is very much low. C9, C17, right? So C1, C19, and C17 are error correction terms, right? Now, let us try to identify the short run causal effects. So for that purpose, see, these are short run causal effects, C2 to C8. Now I'll not include C1, C9, and C17. Why I'm saying C1, C19, and C17 are long run? Just see. See, this is C1, which was an error correction term. In this equation, this is C9. In this equation, C17 is an error correction term. And it should be significant and negative. Done? These are all short run. Now, again, the story repeats from here. What we will have to do? Granger causality, pairwise Granger causation, everything will repeat here. The same story of war. Clear? The same story of war. If you want to see, I will roll it. I'll go here in lag structure, Granger causality test, same. Fine. Once this has been established, now we will not be able to run Wald coefficient test because this test is not available only in VECM structure, right? Wald coefficient test is not available in VECM structure, right? Definitely we'll be able to run the Granger causality. I will again go in group statistics, Granger causality, run all of them together and click OK, and I get the result. Done? Again, from general to specific model, we will pick up some term. After picking up some term, we'll run residual test. As p value is more, so serial correlation not present. Normality test, Cholesky of covariance. Normal distribution is there, but problem is there of third lag. As p value of Jacques-Barra is less than, it means that here in this case errors are not normally distributed. Then we carry out White's heteroscedasticity term. As p value is less than 0.05, we are losing the battleground here also. The residuals are heteroscedastic. Variance decomposition. Again, I'll go back from that only. View variance decomposition. Same thing I'll get here. Click OK. I'll see from graphs, right? Is it clear? Is it clear? Now, talking about myself. Varun sir, I will just take 2-3 minutes more of you. Be attentive. So I am into the teachers training program, right? Those who have not joined my my WhatsApp channel, they are not aware about my work, or those who are listening me for the first time, that I am teaching somewhere around, we are teaching somewhere around 40 softwares like SPSS, StatCraft, Jamovi, Minitab, MATLAB, Gretchen, EViews, MS, SmartPLS, Edenco. And sir, it's my request to you, please take 2 minutes on rolling beta, how to calculate it. Yes. SPSS MS, Smart PLS, Ed&Co, DOE, Design Expert, Atlas.ti, NVivo, Orange, RStudio, R Commander. These all softwares are there, on which I give the training. Now, if you want to be part of my channel, I'm just dropping my details, contact details here in this box, chat box also. You can be in touch with me, right? This is one way. The second thing is I'm dropping one link. It is a DM link by which you can join my vast network of DM, in which there are somewhere around 2,000 faculties from all over the world, right? If you want to join. By joining in this group, you will be getting the notification of all my upcoming programs related to the statistics. By joining in this group, you can even post the programs which are related to, say, for example, if you are organizing some event and you want to be the part, you want to post the brochures, your brochures into my group, you are allowed to do that. You can do the promotions of your program also in my group. Okay. 3 things are not allowed: politics, religions, and pornography is not allowed. If I found somebody doing that thing, you will be debarred. Another thing is, if you are writing some paper on econometrics and you want some like-minded academicians from across the India or around the globe, you just have to post me that, sir, I'm writing this paper. Can you search for me any like-minded person who is working on this? So definitely this DM network, which is consisting of 8 channels like DM, DM1, DM2, I'll be able to find it out, right? I'll be able to find it out. Now the question is, what is the rolling window? Let's understand. What is the rolling window? You will have to install this rolling window. It is in here, or it will be in forecasting. Charts, because I was using this. Yeah, here. Just a minute. Manage adding. Yeah, here it is. Fan chart. Let us see how we used to do it first in EViews 6 and 7. Basically, we wanted to find out that suppose a data is given and then we want to predict that what will happen, the dynamic window, which is there, not a static window, which is there. Just a minute. So this program was there, which we had installed, in which you have to change only the red color buttons. This program is readily available. This we used to do it manually, right? And we will change the sample window. This from first observation, this will be changed, and Y and X the data is feeding. And here we write our regression equation and then we run the model. And what we used to get is this fan chart. This has been replaced by the fan chart that now I directly get in the option possibly. First, let me run the equation and let me see that am I getting it or not, right? So I'll move this one, get it. Block, make system order by variable. Here, copy, quick estimate equation, control V, okay. Forecast. In forecast, there is a dynamic forecast, and this is there. Click OK. And here I should get why is it not showing? Anyway, Anshul, I will try to solve it personally, right? In rolling window, what it is, right? So over to you, Varun sir. Hello.
Thank you, sir.
I'll solve it personally. Don't worry, right? Don't worry. I'll try to figure out how to it is to be conducted, right?
Thank you so much, sir, for such an amazing session. So the platform is open for the questions. Everyone, I am unmuting. You can ask your questions.
Kritika ma'am, what are the steps to be followed to apply GARS model in relation to stock market volatility? Now, GARS model is a thing, ma'am, in which we want heteroscedasticity in the residual. And when there is a heteroscedasticity in the residual, we are making the model from that heteroscedasticity only. We take sigma square. So that thing sometimes later on it takes some time, not right now, because it's again it requires an explanation.
Okay, sir. Sir, actually, I was asking like we have studied today in other models like VAR and as well as VCM. Similarly, in Gauge model also we need to test the normality.
We don't require to test the normality because you will never achieve the normality. Remember one thing, you remember. Who is it? Kritika.
Yes, sir.
My first question is, Ansul, I know. Can we apply NRDL in EViews? No, you cannot apply NRDL in EViews. It's not possible. My question, Ansul, is those who know econometrics. I don't know what's going on. Please, organizers.
Yes, sir, done. There was some glitch.
My question is, you must have read Damodar Gujarati and good books you must have read. Anywhere you came across that you require normality in the data? Anybody, anywhere? Anywhere? In any assumptions? Is there, have you read that thing? Say yes or no. So we don't require normality in the data, but we require normality in residuals. This is the basic difference in cross section and time series. Is it clear, Kritika?
Yes, sir. Sir,
Okay.
actually, I think I got confused with the term normality. I think I should mean it as stationarity, sir.
Stationarity, yes, of course, stationarity. All these models require stationarity. There is no model on the earth which can work on non-stationary time series. What you are saying is that heteroscedasticity, which is there, mean will be, see, there is a very high heteroscedasticity. It means variance is fluctuating like anything. So in that scenario, if heteroscedasticity is accepted, variance is there, then we go in gas model. Yeah, you are right in that terms that we don't go for stationarity gas models. Yes, you can say that also, right?
Okay, okay. Thank you, sir.
Any other question? Any other question? Any other question?
Sir, I have one question.
सर
NARDL अप्लाई करने के लिए पहले हमें वोलेटिलिटी चेक करनी पड़ेगी कि हमारी सिमेट्री है कि एसिमेट्रिक. अगर एसिमेट्रिक इन केस होगी बाय थ्रू ई गार्च और टी गार्च, देन आफ्टर वी कैन अप्लाई NADL मॉडल.
Right, you're right.
Okay,
You're
sir.
right. You're right. Right. Any other question? Anybody who any feedback? Did you understood? Was it good? Any feedback?
I hope all your doubts are clear. I have some announcement. Okay, in the chat box we have some one question. So
For
can you take a
original, this post forecasting, we should always use original series even after differentiating. Not at all. Never, never. After differentiating, you have to work on that series which is stationary. If you are not going to use this series, then why we are doing the differences? Why we are taking so much pain? Once the series has been converted, matter is gone. We are taking this pain to cure the disease.
Any more questions, anyone? Okay, I have some announcement to make. So here in the chat box, we are sending the feedback link. Please do send your feedbacks and your certificates will be available within 10 days and the video of the session will be sent you. And please subscribe the YouTube channel for these sessions. You will get informed about these sessions. And to continue further, I would like to call Mr. Piyush Gupta.
Thank you, ma'am. Very good evening to all of you. Myself, Piyush Gupta, Joint Organizing Secretaries and Assistant Professor of Maharana Pratap Government PG College, Hardoi. I hope all of you have enjoyed this 3-day online hands-on workshop on the topic of econometric analysis using EViews, organized by Association for Academic Research and Innovation. First of all, I would like to thank Dr. Dhaval Mehta sir, Assistant Professor, V. Narmad, South Gujarat University, Surat, for explaining everything very clearly. I would also like to thank joint conveners, Professor Pradipta Banerjee, Department of Commerce, Sidhu Kano, Birsa University, West Bengal, and Dr. Dharan Kumar Pandey, PG Department of Commerce, Magadh University, Bodh Gaya, Bihar. Joint Organizing Secretary, Mr. Varun Kumar Rai, Research Scholar, Department of Commerce, Delhi School of Economics, Delhi, and Treasurer, Dr. Vivek Sankar, Assistant Professor, KPS College, Nadwan, Patna, Bihar, and Session Coordinators, Ms. Arunima Dikshit, Postgraduated Sri Ram College of Commerce, University of Delhi, for organizing these wonderful sessions. And also thanks to media person for covering this workshop. And my special thanks to all the participants, because without you, all the efforts are useless. I hope This workshop is fruitful to all the participants, especially for research scholars, those who can use these models in their research work. So thank you everyone. I hope all of you have enjoyed this session a lot, and we will meet soon with another topic in another workshop. So thank you everyone. Take care. Good evening.
Thank you, Piyush sir, for inviting me on your esteemed platform. Thank you, Varun sir, for inviting me, for locating, for giving me opportunity. Thank you, all of you. Thank you.
Thank you, everyone. For any queries, feel free to mail on. I will sending the mail on the WhatsApp group. Okay. Thank you. Thank you, everyone.